For nearly 50 years, Voyager 1 drifted through the silent void of interstellar space forgotten by most, its mission presumed long complete. But on the 22nd of October, 2024, the aging probe broke its silence with a discovery so violent, so unexpected, it shook the foundations of modern astrophysics. GRB 22109A, a cosmic sniper's bullet. The event was given a cold, scientific name, GRB 22109A, but no name could capture the monstrosity of what it truly was. It wasn't just the most powerful gamma-ray burst ever recorded. It was an eruption of pure energy so bright, so focused, it felt less like an explosion and more like an attack. Picture the combined brightness of millions of galaxies funneled into a single, surgical beam hurtling through space at nearly the speed of light. That's what struck Voyager first. That's what reached Earth shortly after. In the months that followed, physicists around the globe scrambled to explain the unexplainable. Some hypothesized that it was the death throes of a collapsing supermassive star. Others pointed toward a neutron-star merger. But no theory could account for the extreme anomalies. The tightness of the jet, the bizarre radio afterglow, the spectral patterns that didn't match anything in existing models. It was as if the universe itself had bent its own rules to allow this to happen. This wasn't just a burst, it was a violation, a breach in cosmic order. Light as a weapon. Then came April 2025. With the help of the James Webb Space Telescope, scientists finally traced the burst's origin and were stunned by what they found. No neutron-star collision, no exotic black hole. The source was something deceptively simple, a supernova. But this wasn't just any exploding star. This one had launched a jet so precisely focused, so devastatingly narrow, that it turned a natural explosion into a cosmic weapon. A sniper's shot, fired across time and space, with Voyager 1 and Earth dead in its sights. The energy wasn't just vast, it was aimed, it was targeted. And the more researchers examined the data, the clearer it became this burst didn't just break records. It rewrote the physics of stellar death. And still, many believe there's more to uncover. Perhaps unknown cosmic mechanics amplified the explosion even further. Perhaps there are forces at work we've yet to name. The questions that remain are heavier, darker, and far more unsettling than any answer we've found. A universe that screams. The discovery of GRB 22109A wasn't just a surprise. It was a revelation of violent correction to everything we thought we knew. For decades, gamma-ray bursts had been catalogued, charted, and categorized. They were destructive, yes, but still part of a broader pattern. A star dies, a black hole is born. Radiation spills out in a burst of energy, and the universe moves on. But this thing was different. It tore through that comfortable narrative like a blade through silk. Scientists struggled. They revisited old equations, rewrote simulations, and argued behind closed doors. The burst's brightness defied logic. Its afterglow, which should have faded predictably, burned with unnatural persistence. And the jet itself so concentrated, so focused it, suggested a level of precision no natural process should possess. What if this wasn't just a larger burst, but a different kind of event altogether? What if GRB 22109A wasn't an exception to the rule, but the beginning of a new one? For the first time in generations, leading physicist men and women whose names are etched into textbooks found themselves facing a blank slate, a new reality. One where even simple phenomena, like a star exploding, could give birth to something that nearly broke the sky. And all of this, all of it, had been recorded by a probe launched in the disco era. A spacecraft powered by plutonium, older than most of the scientists analyzing its final scream. The universe laughs at our models. We've always believed that science, given time, would fill in the blanks. That with better instruments and sharper minds, we would eventually understand the rules of everything. GRB 22109A mocked that belief. It wasn't just brighter, it was smarter. Every part of its behavior, the way the beam traveled, the energy distribution, The strange interaction with space itself defied simulation. It danced outside our models like a ghost slipping past locked doors, and that terrified the people who understood it best. Because if this event came from something as common as a supernova, how many others like it had we missed? How many lurk in the cosmic dark, their beams narrowly missing Earth by chance alone? What if GRB 22109A wasn't an outlier, but a glimpse of what lies ahead? We once looked to the skies for comfort. We charted the stars not just out of curiosity, but to prove that the universe followed a pattern that it could be understood. But what Voyager 1 recorded didn't just challenge that hope, it shattered it. It forced us to consider that the universe doesn't just allow chaos, it is chaos. And our models? They are polite lies, tools for surviving in a reality far stranger than we ever dared to imagine. A witness beyond the heliosphere. Voyager 1's position at the time of the event was crucial. Had it still been within the heliosphere, the solar system's magnetic cocoon gamma-ray burst would have been distorted, softened, filtered through solar winds and electromagnetic noise. But Voyager was outside, far beyond the last whispers of the sun's protection. It was naked in the dark, fully exposed to deep space as no other spacecraft had ever been. What it felt, what it measured, was not just a burst of radiation. It was a collision between raw cosmic force and the very scaffolding of space. Some researchers now believe that GRB 22109A didn't just travel through space. It interacted with it. It bent it, twisted it. Like a blade dragging through stretched canvas, the burst may have disturbed the very structure of spacetime. The implications are staggering. There are whispers in physics circles, now hushed conversations, not ready for press releases, that perhaps the vacuum of space is more volatile than we thought. That it's not empty at all, but filled with hidden frameworks, unseen fields, tension points we've never accounted for. And when a force like GRB 22109 crashes into those fragile lattices, reality itself might ripple. Voyager 1, in its final act, may have witnessed more than an explosion. It may have glimpsed the bones of the universe shuddering under the weight of something no one saw coming. The slow death of our last eyes. Even as Voyager 1 delivered this seismic warning across the stars, another truth began to set in, far more human. Our greatest explorers are dying. Of the 10 scientific instruments originally aboard Voyager 1, only 3 remain operational. Every year, NASA powers down more systems, trying to squeeze just a few more months out of a machine that should have gone silent decades ago. Technicians at Mission Control, many of whom weren't even born when Voyager launched, now work with instructions that take over 20 hours to reach the spacecraft. Every signal sent is a gamble. Every response a prayer. NASA hopes to keep the Voyagers running into the early 2030s, but the truth is hard and cold. We are watching the last flickers of the only man-made objects in interstellar space. And when they go silent, when Voyager 1 and 2 fall quiet, for good a kind of darkness will fall. Not just across deep space, but inside us. We will be blind to the frontier, deaf to whatever storms may gather out there. And whatever comes next, whatever forces may rise, or events may unfold, we won't see it coming. Unless we act. Unless we build again, launch again, dare again. Because if Voyager 1's final message teaches us anything, it's that the universe doesn't wait for us to be ready. It simply is. Violent, indifferent, and always moving. Echoes from a cosmic battlefield. As scientists combed through Voyager 1's transmission, an unsettling truth began to emerge. GRB 22109A wasn't just powerful, it wasn't just unexpected, it was something worse. It was deliberate. Not in the sense of intent, of course stars don't plot and space doesn't aim. But the nature of the burst, its precision, its violence, pointed toward a universe far more chaotic than anyone had imagined. It forced researchers to confront the possibility that what we'd witnessed was no fluke, no accident of cosmic timing. It was a symptom, a glimpse into the true nature of our galaxia place, not governed by quiet entropy, but by cataclysm, a universe that doesn't wind down gently, but explodes in pulses of rage. If a simple supernovan event we believed we understood could trigger such devastation, What else might be out there? What else have we misunderstood? What terrors lie hidden, masked by our ignorance and lulled by our certainty? Maybe Voyager 1's transmission wasn't just a message about one burst. Maybe it was a crack in the lens through which we see reality. Because if the laws of physics bent once, they can bend again. And next time, we may not have a probe waiting to catch it. The lie of predictability. Gamma-ray bursts have long been part of astrophysics. Their discovery in the 1960s introduced a new layer of cosmic violence, but one we believed we could manage. They had patterns. They had causes. Dying stars. Colliding corpses of matter. Extreme, yes, but chartable. GRB 22109. A. Destroyed that confidence. This wasn't contained chaos. It wasn't the predictable violence of nature. It was something raw, something uncontained. A phenomenon with behavior that refused to match our models. The narrowness of the jet, the longevity of the afterglow, the unexpected radiation spikes. They were all warnings written in light. A whisper from the cosmos saying, "You know nothing." And perhaps that's the cruelest lesson. For all our knowledge, all our telescopes, and all our equations, we are still crawling in the dark. We map constellations like cave paintings, believing they hold truth. But the universe doesn't care for our diagrams. It does not owe us sense. To the cosmos, we are not explorers. We are observers temporary, fragile, and vastly out of our depth. And sometimes, it reminds us of that. Sometimes, with a flash so bright, it sears through galaxies. A fragile machine, a final gift. There is a strange poetry to it all. Voyager 1 wasn't built to see this. It was launched to photograph Jupiter, to give us a peek at Saturn. Its instruments were never meant to endure the silence of deep space, let alone survive long enough to witness a once-in-a-universe event. And yet, it did. Against all odds, this aging craft with its sputtering systems and outdated circuitry became the lone witness to a spectacle that humbled even the best of us. A messenger not of triumph, but of terror. In its final act, Voyager 1 became more than a probe. It became a mirror. It showed us that we are still infants in the cosmic cradle, that our understanding is a flickering candle in a hurricane. And it reminded us, perhaps for the last time, that the unknown isn't just out there. It's everywhere. Silence on the horizon. Soon, Voyager 1 will fall silent. Not with drama, not with a bang. Just a whisper growing quieter until it's gone. No lights, no explosions. Just the end of a signal that began before most of us were born. And with that silence, something larger will vanish. Our only voice beyond the edge. Our last scout in the interstellar dark. We may build others. We may send more. But for a time, we will be blind, deaf, alone. And the universe, as it always does, will continue on bursting, collapsing, shifting in ways we'll never see. Until we return, the question that remains. In the wake of GRB 22109A, one question lingers. It hangs in labs, in observatories, and in the minds of those who understand what really happened. What if this wasn't rare? What if this kind of cosmic violence is not the exception, but the rule? We look at the stars for comfort, for guidance, for hope. But maybe they've been trying to warn us. Maybe their beauty is camouflage. Maybe their silence hides storms. And maybe, just maybe, Voyager 1's final message was not about the universe at all. Maybe it was about us. About our arrogance, our assumptions, our insistence that we know what's coming next. Because the truth is, we don't. We never did. A message written in fire. Voyager 1 was launched with a simple dream to discover, to stretch the limits of what we knew, to go where nothing human had gone before. But no one could have foreseen this. That nearly 50 years later, it wouldn't just deliver images of distant worlds, but a final, trembling whisper from the edge of everything. A warning. A message. Carved in fire across the fabric of reality. It didn't say, "Look how far we've come." It said, "You have no idea what lies ahead." And maybe that's the truest legacy of Voyager 1, not what it taught us, but what it revealed we still don't know. The gamma ray burst it recorded wasn't just the most powerful ever seen. It was a reminder that the universe is not gentle. It is wild, it is violent, and it does not wait. So now we must ask ourselves, what else is out there? What moves in the dark while we're blind? What burns while we sleep? And when the next burst comes, will we be ready? Voyager's final signal may be its last gasp or the universe's first warning, so tap the screen for more.